All right, good morning. I'll plan to do the Leetcode contest, biweekly contest 72. And unfortunately, I didn't do this last Saturday. So here we go. Choop. All right, time to shine. Open these guys up. Okay, count equal and divisible pairs, zero index array, and in K. Number of pairs, ij, where I is less than or equal to j is less than n, they're equal, and I times j is divisible by k. Okay, well, these values are pretty small. It's 100, so we can just do a brute force first pass. Let's do this. Keep track of how long this is going to take. And it should maybe take 5 minutes or so. I don't know. Maybe less than that. For auto I is 0, I is less than n. All right, I is less than n. Plus I. For auto j, I plus 1. J is less than n. If I times j is evenly divisible by k, modulus k, f equals 0. If a sub I equals a sub j, and that, then we'll increment the count, CNT, and then return count. Okay, that looks good. Uh-oh, wrong answer. Output was 17, and we expected 4. All right. Okay, what did I do wrong? Right. I equals j, and I times k is j is divisible by k. Oh, uh-oh. And I times. Okay, so my parens are off. Let's see, it should be 4. 4 and 0. Okay, let's try this again. Okay, accepted. Oops. Okay, look closely at what's going on and observe more closely in order to avoid a bug. Anyhow, it's 2 minutes for a brute force algorithm, and then, I don't know, can we do something faster, better? If I is equal to j, then we can do some pre-processing, right? And pre-processing of the values and put those values in the map and then just compare the indices associated with those values. So that would be something that trades time for space. That is, with pre-processing, we can save a little bit of time, right? Let's just do that real quick. Just use a map. All right, so just delete this thing, start over. Okay. 6:05 a.m. Use a map. Map which stores same value buckets of index to compare. All right, indices, I guess indices. Okay, cool. All right, let's do this. So let's have a map. Yeah, just a hash table. It's unordered map for O of 1 lookups, inserts, deletions. And stick this in here. Map. Okay, for each value x of a, we'll increment. Oh wait, hold on. Actually, we want the index for auto I is less than size. Okay, and then m sub a sub I, and actually this needs to be, we'll do this vector integers back, push back the index I for the value a sub I. Okay, and then for auto value x, and then the list of index in the map, or Okay, so for each index I, and then for each index j. So let's do this. I is 0, I is less than index dot size. Okay, so this will be a little bit improvement, but not maybe that great. I plus 1, j is less than index dot size. Do this, int n equals index dot size. I don't have to use that twice. Lowercase n, since that's just the list of indexes. If I times j modulus k is 0, let's do this. I count plus equals that. Ready, and then return count. 5 is not right. Should be 4, right? Each value, oh, index. Okay, so I cannot equal, wait, I can't equal j. That's right. I times j modulus 0. What? How is it coming up with 5? Let's see. I, j, if, let's just do this, only print it if this is true. Increment the count and output that. Let's do this. Okay, I is 0 and j. Okay, hold on, for which index? I is 0, j is 1 and 2. Index. Oh, wait, hold on. I in index, j in index. I just not equal j, right? I is not equal to j, and that, I think that works. Right, that should be legit. No, it's not. Uh-oh. Value, oh, buckets. Index at that value. 0, 1, 2, and 3, 2, and 4. Oh, then it does 4 and 2. Okay, so I has to be less than j. I is less than j. Right, okay, that looks cool. Count plus equals, I is less than j and that should be good. Oop. Okay. And that's a little bit faster, I think. Right, same value buckets of indices to, what did I write here? Buckets of indices to, yeah, consider. Right, these are potential candidate buckets, right? And this one's kind of a less naive algorithm, so I'll write that in the other languages as well. Just use a map and then go through the indices of each map. Okay, let's write this real quick in Python. Okay, map is, let's do this, a default dictionary. That way I don't have to consider if the key doesn't exist. It'll put the default dictionary key value of undo list. For each value x and a, m sub, let's do this ix and enumerate a. So we hit the index, and we want to associate the index with the value. Right, there we go. So append those into buckets, and then for each value x, the bucket of index, in items. Actually, we'll do values for index in m.values, since we don't need the key. Let's do this. Count 0. Turn the count at the end, and then we'll do for I in index, for j in index, if I is less than j, and I times j modulus k 0. This count plus equals that guy. Ready? It's good. It's cool. Okay, 6:11, 6:12, about a minute. Sounds good. About 1 minute. It's okay. Grab this. Stick it in here. Okay. Next, let's do JavaScript and then Kotlin. Okay, 6:13. Oops, 6:13 a.m. Okay, let's go. Here we go. For let's x of a. Stick that in our map. Actually, I need the index too. Okay, so that set I that gets. Hold on. If not, m dot has a sub I, then m dot set a sub I to an empty list, and then m dot get a sub I dot push I. I push each ith index onto each value, and then for let underscore index list of m I of index for let j of index I is less than j, and I times j modulus k is 0, then we'll increment the count let's go transform that into a number, and then we'll return the count. I guess we don't need this thing here. Count. Uh-oh, count is not defined. Okay. Count 0. Okay, looks good. Bam. 6:15. About 2 minutes or so, 1 or 2 minutes. Alrighty. I don't think I need in, by the way, so I can probably go back here and script. Stick that there. And we don't need, right, just move this one like that. Looks good. Okay, let's write this in Kotlin real quick, and then I don't know if I want to do rest or not. Maybe I do rest, whatever. Okay, so for x and a, rm equals mutable map of int, and that's to a mutable list of integers, which put the index for x and a. If the map does not contain x, then what we'll do is say m sub x equals mutable list of integers. Okie dokie, and then m sub x dot add. We need an I. Okay, hold on. I x in a dot with index I. Okay, and then for each value in the map, we only care about the index. For I in index, or j in index, if I is less than j, count plus equals if I is less than j and I times j just k equals 0, 1, now 0. I think that works. And then count to 0, return the count. Good. There we go. Okay, let's see what happens. Expecting in, oops, it should be in, not of. In. Of is the JavaScript thing. Okay, that looks good. Okay, oops, I didn't time myself, but it took about a minute or so, a minute or two. Okay, Kotlin. Might as well, whatever, we'll struggle with a little bit of Rust. All right, type vi equals spec 32. Let's stick that up there. vi k let mute count equals 0. Return that count at the end. And then for x in a dot iter dot enumerate. Oops, I think that works. My x in this. Now let me just print this out and see what happens. I think it'll work, but I better check as I go. Unexpected common pattern. Okay, hold on. Let me look this up. Rest array with index soup for each. Okay, what does this guy say? Ix. Oh, it needs parentheses around it then? Okay. Okay, that makes sense. It's parentheses to destructure. Okay, that looks right. Okay, so let's m equals hash map, and we'll use std collections hash map new, I think, something like that. Okay, so if not m dot contains x, m dot insert x, and then I want to insert vector that I can push back to. Right, I think we can use a vector macro. M. Oh, hold on, I'm not sure what the syntax is. IntelliJ idea. Let me open up my Rust editor here. I'm gonna look this up. Obviously, I want to get what's there and then update it. I want to push the index onto the back of the list. Hold on, bear with me. I'm gonna look at my notes for Rust. Okay, yeah, I got this. Oop. Ah, okay. I got this hello world going here, and let's look at hash map. Okay, entry, m.entry, shape sides. Insert. Okay, I'll probably just have to just hack on it and see what happens. And m.get is the object I want to get, right? hold on. Get the entry and then update it, especially what I want to do. Okay, I should be able to do m.entry. Let mute entry equals m.entry or insert or insert. We want to insert a vector. And then dereference entry and then place into it push. Let's see what happens. Push type cannot be dereferenced. Entry or insert. Entry.push. Cannot borrow m as mutable. Okay, let's mute m. I do want to modify that map. Okay, cool, that works, I think. Let's see. For each value in the map, let's see how to iterate through the values. Just dereference it. Okay, cool. For x index in m, let's just see what's here. X, and then debug output for index. Okay, let's see what these buckets look like in Rust. Okay, that looks right. Cool. Okie dokie. For I in index or j in index, if I is less than j and I times j modulus k is 0, then we'll do count plus equals 1. Whoa. No implementation for usize modulus I32. Usize as I32. Wait, as usize. Usize, that should work, I think. Yay, okay, let's see what happens. Okay, cool. A little rusty on Rust, but you got there eventually, so that's cool. Okay, and let's post this and then move on. 6:25 is when I end this thing. 6:25, so it's about 20 minutes for each. Takes a little bit of time to type it, I guess. All right, post this. Pretty naive solution, nothing too fancy. Good way to start off, I suppose. View solutions. Alrighty, a little description here. Use a map to associate, I guess to create buckets of same value x indices, buckets of index for each same value x. Then consider each I, j index pair as a candidate, which for which we increment the count per the problem statement, right? I don't need to Mention the same thing redundantly. And use map to create buckets. Index for each same value x, then consider each ij index pair as a candidate for which we increment the count per the problem statement. Yep, that sounds right. And that looks legit. Okay, cool. Next. Find 3 consecutive integers at some to give an number. 10 to the 15th. Holy cow, this thing's huge. If num cannot be expressed as the sum of 3 consecutive integers, return an empty array. 3 consecutive integers? There's no way to express 4 as the sum of 3 consecutive integers. 33 can express as 10 plus 11 plus 12. Okay, so it looks like a sliding window, but then a long. Is that big enough? Like, holy cow, that thing's huge. So what is it saying? This is the sum of 3. We're outputting these values. Long num. Okay, so this one will definitely be easier in Python 3. Start off easy. Since Python 3 handles big numbers well, right? I don't really have to do anything. Let's put the time here. 6:28 a.m. Okay. Basically, I'm given a number. I mean, huge, 15 zeros. It's gigantic. Okay, so I'm looking for 3 numbers that add up to that number. So what do I do? Divided by 3? Minus 1 and plus 1? I guess, yeah, right. Offhand, I guess we can take x and divide it by 3. Let this value be k, then return an array, k minus 1, k plus 1, maybe something like that. Let's see if do for 33, it'll work out, right? 33 divided by 3 equals 11. So if k equals 11, right, then k minus 1 is 10, and then k plus 1 is 12, right? And then 11 plus 12 plus 11 equals that. Okay, well, let's see what happens. K equals x divided by 3. Return k minus 1, k plus 1 if k minus 1 wait, hold on. If it equals x, else empty string. Let's see what happens. This solved it correctly. Yeah, well, let's just, maybe I didn't try with a different input, but what would 34 do? All right, let's see, 34. Still be 11, right? But this would be empty string or empty array. Yeah, let's see what happens. Okay, well, this is kind of like silly, right? This is kind of silly because Python 3 handles these big numbers for me on my behalf, right? So well, anyhow, I did solve this one pretty quick. 6:31 a.m. Quick solve, kind of cheating, right? With Python. Well, if you don't want to kind of cheat, then let's just see what happens when we do this, right? The OJ is really hard on. It's really hard on C++. Like, it gives C++ a hard time with TLing and such. Okay, well, let's see what happens. Okay equals x divided by 3. If, let's see, return k minus 1 plus k plus 1 equals x. And we'll return VL k minus 1, k plus 1. I guess what we can call this thing a candidate, right? VL cand. Let's see. If accumulate, can that begin, can that end, 0 equals x, then we'll return canned. Otherwise, we will return just empty. I don't know. This looks kind of ugly. Let's do this. K minus 1 plus k. This is basically just 3 times k equals x. If it does, then that. If not, then that. Right? Okay, whatever. Okay, well, this is silly, but whatever. Okay, so far the first 2 questions have obviously lacked augmented complexity. They're pretty naive. So I might as well put my walk the walk rather than just talk the talk and do this in Rust as well. If, hold on, return. Oh, if it's evenly divisible by 3, I see, okay. Yeah, so if x modulus 3, and then we can do this, right? Just basically turn it into a one-liner and a self x divided by 3, x divided by 3, x divided by 3. Whoa. Invalid syntax. Oh. All right, that was good. Yay. Okay, cool. It's kind of fun, I guess. Making a one-liner makes it a little bit more interesting, I suppose. Hold on. Let me modify my C++ real quick. Might as well write it the same, right? Well. Well, yeah, C++ doesn't allow lambdas anyhow. Whatever. Well, it doesn't allow lambdas, but it doesn't allow one-liner this way. Whatever. Okay, I don't need to nitpick it. Let's just keep going. All right, this is silly. I don't want to waste a bunch of time on this. Let's get to it and get to the next one. Maybe more interesting questions, Q3 and Q4 perhaps. get some more coffee here too. Okay, anyhow, I'll do this on one-liner. So x modulus 3 x divided by 3 minus 1, x divided by 3. Oh, wait, hold on. Let's do this. K equals x divided by 3. K minus 1, k plus 1. Okay, that looks good. Yes, 3. Yay. All right. JavaScript. Oops. This one is not Rust. We'll come back and do that one last. Do Kotlin next. Okay, let's do this as a lambda as well. This guy. Return that guy. If x modulus 3 is 0, then we'll return what are we supposed to return? What's the return value for Kotlin? Hold on. Default definition. It's a long array. Okay, that makes sense. Long array of x divided by 3 minus 1, x divided by 3, x divided by 3 plus 1. Otherwise, long array of nothing. Cannot be applied to long and int. Okay. There we go. Yay. Okay, now we'll do rest and then get on to something else. Okay, rest. Next. Use VL equals spec I64. Yeah. Or oops, it's not use, it's type. Okay. Then what we can do here is a closure or anonymous function in the rest. I think it worked. Wonder, I don't know if I can do a one-liner or not. Public function sum of 3. X. Let's do this the long way first. Let k equals x divided by 3. Turn if 3 times k is equal to x, then vector of k minus 1, k plus 1. Otherwise, a vector that's empty. Oh, does that work? I'm surprised. Yeah, I wasn't expecting rest to work that first time. Okay, cool. So I'm making some progress. Yay. Do I want to make this a little bit tinier though? This rest does have the closures I could use, right? I think. Let's try. Fn function. Yeah, I don't know. Can I do rest class lambda method? Passing lambdas around. Does this work? use a yeah, I'm not sure if this will compile or not. Yeah, we can just leave this as it's good enough. Not that great of a solution, but it's not that bad either, right? Not too shabby. Yeah, it's okay, whatever. Let's take it and go. Stick that there. Yeah, it looks kind of like the C++, right? And whatever. Could be better, could be worse. Let's move on. Don't be a perfectionist. Already a few solutions. And then we'll describe it. All right, so if the input value x is evenly divisible by 3, then let k equals x divided by 3 and return a vector of k minus 1, k plus 1. That's all there is to it. Otherwise, return an empty vector. Boop. Alrighty, that sounds good. Alrighty, next. So where am I at? About halfway through the contest and I'm all out of coffee. Okay, I'm gonna take a break and I'll go make some more coffee and I'll be right back. Okay, I'm back. Thought I had to brew another cup of coffee, but should pot had enough in there, so I just poured myself a cup. So I'm back early. Okay, we got 45 minutes. The contest is about halfway over. We did 2. We got 2 more to go. So let's hit it. Here we go. Interspecial integer final sum. Split into the sum of maximum number of unique positive even integers. 210, 468, 48, 48 contains the maximum number of integers. That the file sum cannot be split into 2244 because all the numbers should be unique. Okay, that makes sense. Return a list of integers to represent all valued split. Contain the maximum number of integers. Okay. 10 to the 10. Man, some of these values are huge. So again, this is the I suppose something easier in maybe the Python, but there is overlapping substructure and overlapping optimal substructure and overlapping subproblems, right? There's a subproblem within the problem where you can see 2 plus 10, the 10 can be broken out into 4 plus 6. So there is optimal substructure and overlapping subproblems. So this one is looking DP-ish to me offhand because right, we can't possibly consider all sums, right? We need to constrain the output in a way where we're only looking for the maximum number of integers that sum up to that value that are unique. Unique even. Okay, so if the number is odd, obviously there is no unique even, right? So that's half of the value. That's odd, right? Because you can't have evens sum be odd. That's simple enough, and that's something easily forgotten as well. Hold on one sec. Long, vector, long. Okay, VO, long, x. If x and 1, return nada. Right, it's odd. Okay. Otherwise, what are we going to do? Final sum. The final sum should be pivoted somewhere around half of the value, isn't it? 14 would be half of this thing, so it's kind of like a good start. As a heuristic to find the final sum. Yeah, this one's weird offhand. I'm not sure exactly how to find it. Okay, the k here is 4, right? There's 4 values. 2, 4, 60. Yeah, it doesn't make sense to go in a linear fashion considering all of them. That would be too much, but that might be a good start. Just some brute force algorithm and then optimize. Okay, yeah, so I guess that makes sense, right? I don't know. I don't know offhand how to solve this. It doesn't look as trivial, right, as previous 2 questions. So right, let's not get stuck in analysis paralysis. Let's just start with a brute force. And brute force is usually pretty straightforward, right? You just try them all even values. List of integers represent this valid split. No valid split exists. Return empty list. I guess for 4, 4 is 4 would equal. I can't have 2 plus 2, but we can have 0 plus 4. I guess 2 is not unique. Okay, so if you want the maximum sum, it does make sense to have small values, right? Like the 2 does seem to make sense. Because then instead of the 2, 6. Even value. Yeah, how are you going to do brute force? Brute force seems kind of tricky even, isn't it? How would I know 2, 4, 6, 8, 12? Question to ask myself is how would I figure out that 2 plus 6 plus 8 plus 12 goes 28 is the optimal solution? Even in a brute force manner, this doesn't seem straightforward as I was hoping. Hmm. How would I know to skip 4 and 10? Right, let's see. If let me capitalize my I, give myself some self-respect. Okay. Okay, so how would I know to skip 4 and 10? Now, if I were to consider all even values from 2, right, 4, 6, 8, then what would the running total look like? 1 plus 2 plus 2. Yeah, 4 would be 6. 6 would be 12. 8 will be 20. 10 would be 30. Okay, now we've gone too far. It's basically like we've overshot 28. So what does that mean? We've overshot 28 by 2. So we can get rid of this and say, hey, all right, we can get rid of this guy. 1, 2, 3, 4. Two. Note that these are also accepted. Hold on. 4, 6, 8, 10. Is it okay? Why is 4, 6, 8, 10 not accepted then? 10, 18. Right, those are all. Oh, etc. Okay. Okay, so accepted then would be 4, 6, 8, 10. That's cool. Okay, 2, 4, 6 is pretty straightforward, right? Okay, let's try other values then. The final sum was 28, but what if we wanted like 32? How about? Our target is 32. And 2, 4, 6, 8, 10, 12 is 40. Okay, now I've exceeded 42. I just dropped the 10. Does that work? Just drop 10 and we have like the vest 32 then? Maybe, yeah. I think that works actually. Now let's implement it, all right, and see what happens. Might as well, right? All right, whatever. Running total. Let's see, while t is less than x, strictly less than x, then we'll do I0 t plus equals I plus equals 2, right? Think of my I and then add that on the t. And then once it's too big, then we want to remove. If t does not equal x, then we'll want to remove how many we've gone above x by. L. Using set of longs. Set the scene. Set scene. Close this guy. Scene. Insert I. They're not equal. So if they're not equal, then we want to drop the value that will make them equal. Scene.erase x. Oh wait, hold on. T. Total's too big, right? Okay, let's see what happens. 12, 6, 4 twos, right? And then 28, try different values. 7's odd, 28, 32. Let's try like 1,000, a bigger number. Seem legit. So 28 is 4, 6, 8, 10, 32, 22. Okay, I mean, it seems all right. Let's see what happens. Oh, wow. This is really surprising. I was not expecting this. I was totally not expecting this. So that's cool. That's pretty cool. Just try, right? Just start and give it a shot. That is fortune favors the brave, right? The risk takers. Just try. Right? Yeah, that's pretty cool. That's a pretty good solution too. I didn't time myself. Dang. Okay. I started about. I had like 45 minutes left. So this took about 15 minutes or so, I'd say. Probably. If I were to guess, is about 15 minutes. Yeah, that was no bugs too. So that's pretty cool. All right. Well, let's write it in the other languages, and then we'll move on. Yeah, sometimes I just need to believe in myself. Like it's kind of silly. I don't have that much confidence in myself. Oh well, I guess confidence takes time to build up. It's okay. I don't be too self-critical myself, right? Just keep going, doing the best I can. That's pretty much all I can do. Yep. I just do my best. Try not the naysayers. Lots of negativity out there, unfortunately. All right, let's see what happens. Let's time ourselves. 7 o'clock. I think this should take less than 5 minutes for sure. All right, so the game plan is if x and 1, we'll return this guy immediately, just empty, because that doesn't work out. And then we'll have our running total, t, and our index, I. And then we'll also have our answer, which will be a set of scene. Okay, for our while, x is strictly less than, wait, but t, the running total is strictly less than x, and t plus equals I, and then I plus equals 2. Scene dot add I. Ready? If total is not equal to x, we'll remove that value. Scene dot remove total minus x, and then return an array of scene. List of scene, right? Oops. There we go. That works. Yay. Okay, 7 o'clock to 7:02. About 2 minutes. Okay, yeah, so the good learning experience here is to trust myself, just dive into it, don't get stuck in the analysis process, just try things out, work with the input, see if we can characterize and find some kind of pattern, basically, right? And I did. Okay, so that's cool. All right, let's do this again here. Do it in JavaScript. 7:02 a.m. and it should take like a minute or two as well. 0, T is 0, and then sometimes JavaScript will be a pain in the ass though with these large numbers. So let's see what happens. You can split T I equals 0. While T is strictly less than X, T plus equals I plus equals 2. Okay, and then we need a set of scene. Set scene dot add I. Okay. If total does not equal X, then scene dot delete T minus X. Total got too big, so remove that. Okay, and then remove or return scene as an array. Right? Okay, let's what? Oh, hold on. 7 is not right. Got that part almost. If X odd, then we'll return this immediately. Looks good. Yay. 7:02 to 7:04. A couple minutes. 2 minutes. Okay. Kotlin's next. Okay, so far total I, and then hold on, if X plus 2 is 1, then we'll return list of long, just like that. Then Ti scene equals triple 0, 0, and mutable set of long. Turn scene.toList. While running total is strictly less than X, and total plus equals I plus equals 2, scene that add I. If the total is not equal to X, then we remove that single value, scene dot remove T minus X. Ready? Uh-oh, cannot be applied to long and int. Ready? Let's do this. Looks good. Yay. Okay, stick this in here. Kotlin. Bam. Okay, and then do rest. Rest is that hairy one. If I'm to get less rusty on rest, I will have to practice rest. Type VL equals fec I64. All right, return that, and then use standard collections. And I want to have a scene as a hash set. Let mutable scene equals hash set new. Okay, hold on, let's do this. If X and 1 is equal to 1, then we'll return Okay, and then I want to change a hash set into a vector. I have to figure out how to do that. Change hash to vector of long. Let's do, and then to have seen. Let's do this. Let's just destructure scene with int as well. Mute mute scene, destructured from that. While the running total is less than x, total plus equals I plus equals 2, and then scene dot insert I. think that works. Let's just return a vector, empty vector for now. And then let's just do some debug print of what's been seen. Okay, let's see what happens. Okay, it doesn't lock those longs. Should be I32 maybe. I don't know. 0 as I64. As I64. Is that cool? As, not is, as. All right, let's see what happens. Yay, okay, it is printing as I'd expect. So that's cool. This one's not printed. Okay, that looks good. Alrighty, let's do this. Yep. Total does not equal x. Oops. Then we want scene dot remove t minus x. Okay, let's see. Rest hash set to vector. Convert the hash set of strings into a vector. How do we do this? Into iter.collect. Okay. Scene dot into iter.collect. See what happens. Nope, it doesn't like that. Expected something to be borrowed. Yay. Taking a while. Yay, okay. I thought I was going to TLE for a second. Alrighty. That looks legit. That's cool. Post this and move on to Q4. Q4 is that unicorn. Alrighty. Few solutions. Let's see, increment a running total t as each even value I from 2 by 2. Increment a running total t by each even value I until, or I guess while t is less than x, where x is the input value. If we've, let's see, overshot our, if the total t exceeds x, then delete the even value t minus x from the ith values seen to be returned. Also note, right, we if x is odd, we return an empty vector. Since the accumulated total of even values cannot result in an odd value. Okay, that looks pretty good, right? It's cool. I'm running total, increment by I, track what's seen, go over it, you overshoot it, you just subtract t minus x. Looks good. Okay, and now the last question. Question 4. We have 18 minutes. Good 18 minutes on her. 18 minutes left in the contest. Time to shine. Okay, here we go. Good triplets in array. Okay, so the order matters. I'm looking for good triplets. Three distinct values in increasing order by position, both nums1 and nums2. A good triplet is a set of three distinct values. They're present in increasing order by position. Two, 0, 1. Out of those triplets only suffices x, hence there's only one good triplet. 10 to the 5th, so this thing's still pretty big. So I'm looking for a linear time algorithm. This one, four good triplets, 403, 403, 402, 402. We have to keep track. Is it to the right or to the left of each other value? 1, 3. This one, it seems that the O of n squared, right? O of n squared at quadratic runtime. Runtime is naive and simple, right? I think so. Or no, it's not quadratic. It'd be be cubic, isn't it? Cubic. All right, so for each I, J, K, right, all I, J, K possibilities are considered in A and B with its vectors. And yeah, that's probably a good start too, right? Again, good start. So let's start implementing. Let's get going. Good triplets. You know, if you can already tell if the good triplet is a long, then we'd probably want to formulate it using the law of product, right? A huge hint here is the input, right? Input cardinality 25, basically 100,000. So that means that we are looking for a linear solution. Right, we can do some basic pre-processing. Pre-processing in login time is okay. Quadratic is definitely not okay, and cubic is definitely not okay. Right, and then also another huge hint, right, in favor of DP is the return value, right? Return type of long. It's a big number. Vector of integers. Okay, A and B. Okay, we'll just go with the naive approach first, just to start us out. Are they the same length? Yes, they are the same length. Then, oh, J, this one, J listening. K, J plus one, K is listening, K, and then the ones in common create a string of scene. Yeah, I guess that works, right? Auto key, I, auto J, auto K, string stream, I, J, K. All right, so that'll be our string, and then we'll have a string of scene. Yeah, hash set. Set. Intersection of the set, I guess we could probably return, right? Set to A, set to B. So F function will return what's been seen. Hold on. Okay, insert that key and return scene. Auto A equals F sub A sub B. Return the intersection of A and B. Actually, I need to do this back inserter into the answer. Okay, the answer. Oh wait, answer dot size. Set intersection. BI and I don't know. What call it same maybe. Same size, right? Auto not allowed in function prototype. Oh, what? Really? What? F equals oop. N cannot be implicitly captured. What is this? I consider, oh, same would be set. Set intersection. What does it complain about? What the heck is this? Something requested here. Back inserter. Oh, it's not back insert, it's just inserter. Isn't it? I thought it was inserter. No matching function call for inserter. Inserter? What? Set intersection. Same as a set, huh? Let's see what we got here. It's the output iterator, right? I thought intersection, read up again. Oh, okay. Cleaned up again. Does that work? Order equals what? Come on. 1, 2, 3, 4, and beat up again. Vector. Vector string. I guess we can put it into the vector. It should be okay, right? Yes. What? It should. I think this should work, right? The output iterator. Or yeah. Well, that's not right. Okay, hold on. Copy that again. Oops. String iterator. If I can type iterator string. Okay, let's just print these things out and see. Oops. And then this is also only just the beginning. This is just a brute force algorithm, which is expected to TLE same. Undeclared identifier O stream. R is in there. Oh, it's ordering them differently. I see. Okay, dang it. I didn't want to do that. Wait. 0, 1, 2. Doesn't look great. IJK. Oh, it should be A sub I, right? A sub I, A sub J, A sub K. The value at that index, right? 0, 1, 3, 2, 0, 1. That looks right. Okay. So there's only one. And the other one, there should be 4. Okay, that looks right. Okay, so this is a valid solution, which is expected to TLE. Valid TLE solution, right? Brute force. And that's a good start, right? Let's see how much time I have left. 3 minutes. And that's about where I'm going to probably end up here. TLE, yes, okay. Okay, so to do, hop on to upsolve this one. Upsolve. The main question is how to remember past to formulate future. I think it is DP. Right, so if you have 2, 0, the 0 has to be right at this 2. You have a 2, 1. Right, I think we just got to keep track of what's to the left and what's to the right of each. Need some pre-processing, right? ITP or pre-processing of input to reduce asymptotic bounds for AC. Okay, and I think that's pretty much all that I got in me for today. The brute force on Q4 and an upsolve. Cool. All right, well, thanks for watching. Catch you next time.